I can solve problems with common factors by using the strategy Make a List. Let's look at this lesson's essential question. How can you use the Make a List strategy to solve problems with common factors? Let's take a look at this following problem. Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels. He wants to arrange the coins in 2 rows. Each row will have the same number of coins, and all the coins in a row will be the same. How many coins can he put in each row? So let's focus first on what is it that they're asking us. Well, let's look at that question. How many coins can he put in each row? Well, we need to find the number of coins that can go in each row so that each row has the same number of coins and all the coins in the row will be the same. So this is important information. And remember, when you are trying to solve a word problem, you have to read it more than once. Sometimes it's going to take 2, 3, and even 4 times in order for you to pull out the important information. So now let's think. What information do we need to use? Well, it says Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels. So that's really important. 30 pennies, 24 quarters, 36 nickels. And of course, remember that each row will have the same number of coins and all the coins in a row will be the same. So now turn and talk to your partner about how you think we can use this information in order to solve this problem. Pause this video until you're ready. Okay, so what can we do in order to solve this problem? Well, we can make a list to find all the factors of 30, 24, and 36. Then we could use a list to find the common factors. A common factor is a factor of 2 or more numbers. So let's go ahead and start that list. So we said that we would have to find the factors of 30, 24, and 36. So let's start listing those factors down. Go ahead and start this in your notebook and pause this video until you're ready. You can go ahead and work with your partner on this. List down the factors of each number. Okay, so let's start with 30. So we have 1 times 30, so 1 and 30 are factors. Then we have 2 and 15. 2 times 15 equals 30. Then we have 3 times 10, so those are both factors. And then we have 5 times 6, that makes 30. Then 6 times 5, and since we have those numbers as factors already, we know that we're done with the factors. Now let's start with 24. So we have 1 times 24, so 1 and 24 are factors. Then we have 2 times 12, so 2 and 12 are factors of 24. Then we have 3 times 8, so those are factors. And then 4 times 6 are factors. 5 is not a factor of 24. And 6 times 4, and we have those factors already, so we know that we're done. Now let's start with 36. 1 times 36. So those are factors. 2 times 18. So those are factors. Then we have 3 times 12 as factors. Then we have 4 times 9 as factors. And then 6 times 6, we only put 1 6 down, so 6 is a factor. Okay, so now we listed down all the factors for our coins here. So we have the factors for 30, the factors for 24, and the factors for 36. Now what we can do is circle the factors that are common to all three numbers. So we have 1, because 1 is a factor for each, 2, 3, well, not 4, because 4 is not a factor of 30, 6, nope, not 10, 8, or 9, not 15, 12, or 12, 34, 24, 36, nope, and that's all we have. So the common factors that we have are 1, 2, 3, and 6. Therefore, Chuck can put 1, 2, 3, or 6 coins in each row. Let's try another problem. Let's look at this following problem. Ryan collects animal figures. He has 45 elephants, 36 zebras, and 18 tigers. He will arrange the figures into rows. Each row will have the same number of figures, and all the figures in a row will be the same. How many figures can be in each row? So, what do you think we have to do in order to figure out this problem? Well, hopefully, the first thing that came to your mind is we have to look at the question itself. So here is that question, and again, we know that is the question part because there is that question mark right there. So let's reread that question. It says, how many figures can be in each row? Okay, so in order to figure out this problem, what do we have to do? Well, we figured out what the question part was. Well, let's reread the problem. Ryan collects animal figures. He has 45 elephants, 36 zebras, and 18 tigers. He will arrange the figures into rows. Each row will have the same number of figures, and all the figures in a row will be the same. How many figures can be in each row? Now let's consider. There's a lot of information here. But what information do we need to use? Pause this video and turn and talk to your partner about this. Okay, so what information do we need? Well, this is important, isn't it? He has 45 elephants, 36 zebras, and 18 tigers. What about this part? He will arrange the figures into rows. Each row will have the same number of figures, and all the figures in a row will be the same. Well, that's important, isn't it? Each row will have the same number of figures, and all the figures in a row will be the same. That's very important. Now think, how will we use this information in order to solve the question, how many figures can be in each row? Pause this video and turn and talk to your partner. Well, we can actually make a list to find all the factors of 45, 36, and 18. Then we can use a list to find the common factors. So go ahead and do this in your book on page 292. You can work with your partner. Pause this video until you're ready. Okay, so let's start making our lists. So the factors of 45. So let's do it in order so we don't forget anything. So we have 1 and 45. 1 times 45, right? So 1 and 45 are factors. 3 times 15 makes 45. So 3 and 15 are factors. And then 5 times 9 makes 45. So 5 and 9 are factors. And that's it. So let's start with 36. So we have 1 and 36. 1 times 36. Then we have 2 times 18. That makes 36. 3 times 12. So 3 and 12 are factors. We also have 4 times 9 makes 36. So 4 and 9 are factors. And then 6 times 6 makes 36. So 6 is a factor. And that's it. And lastly, let's list down the factors of 18. So again, in order, we have 1 times 18. So 1 and 18 are factors. Then we have 2 times 9. So 2 and 9 are factors of 18. And then 3 times 6 makes 18. And that's actually it. So here are our factors. Now, let's circle our common factors. So 1, we already know that, right? So we have 1, 3, 2, 2. Nope, but 3, 3, 3. 3, 3, and 3. Let's see. Then 5. Nope. 5 is not a common factor. How about 4? Nope. 9. Yep, 9, 9, 9. So let's go ahead and circle that. And we can go to the next one. 15. Is 15 a factor of 36? Nope. So that is not a common factor. And 45. Nope. So the common factors are just 1, 3, and 9. So in other words, Ryan can put 1, 3, or 9 figures in each row. So by making a list, we were able to see all the factors of each number, and then we were able to circle the common factors in order to solve this problem. So let's go back to our essential question that we began the lesson with. How can you use the make-a-list strategy to solve problems with common factors? Pause this video and turn and talk to your partner. In this lesson, you learn how to solve problems with common factors by using the strategy Make a List.